This is video 3.7b, the elimination method. We are on example number 5, and we have 3x plus 5y equals 7. No, it's negative 7. And we have 5x, alright Gary, 5x plus 4y equals 10. Alright, so let's eliminate. Let's see. We can do this a couple different ways. We can try to get my y's the same number. The common number for 4 and 5 would be 20. Here I could get this 3 to be a 15 and this 5 to be a 15 and go from there. So let's do something different. Let's make these 20s. So in order to make this top one 20, I have to multiply the whole thing by 4, because then that would give me 20 when I multiply 4 times 5. So that's 12x plus 20y equals negative 28. Okay, and then we're going to multiply this by a negative 5 so that we can make that a negative 20. So negative 25x minus 20y equals negative 5 times 10 is negative 50. Okay, and I'm going to add those. These are going to go away. 12 plus negative 25 is going to be negative 13x. And negative 28 plus negative 50 is negative 78. Divide by negative 13, divide by negative 13, and x equals negative and a negative is a positive. 78 divided by 13 is 6. So that's my x value. Now I'm going to plug that x into any one of these 4 equations. Doesn't matter which one. So let's plug it into the top. (18 plus 5y equals negative 7). Subtract 18, subtract 18. 5y equals negative 25. Divide by 5, divide by 5. Y equals negative 5. Okay, so we're going to take that and plug it in one of our equations up here. Let's pick the second one. And we're going to put negative 5 in there for y. Four times negative 5 is negative 20. Add 20. Add 20, so we have 5x equals 30. Divide by 5, divide by 5, those go away, x equals 6. So I get for my answer an x value of 6, a y value of negative 5. So example 6, we have 1/2 x minus 1/3 y equals 2. 1/4 x plus 2/3 y equals 6. Now, I don't know about you, but I hate working with fractions. So if you remember, we look at our common denominator. This one is 6, so we're going to multiply the entire thing by 6. And that gives me 6 over 2 x minus 6 over 3 y equals 12. 6 over 2 is 3. 6 over 3 is 2. And we just transformed this equation into this one. So this is the one that we're going to look at for that. Now we're going to do the same thing with this bottom one. Common denominator for that, we've got a 4 and a 3. So we would love to see that be multiplied and become something other than a fraction. So our common denominator is 12. So we multiply this times this and we get 12 over 4x. 24 over 3y equals 12 times 6 is 72. 12 over 4 is 3. 24 over 3 is 8. And we have 72. So there is our other equation. So we just got rid of these fractions here, and now we have these two equations here to use. Alright, so what we're going to do here is we're basically starting over using that equation and that equation. Now let's put a plus sign here because that's what I've got there. Alright, so now these numbers here are the same except one has to be opposite in value. So if we change the sign of that and change the sign of the 8 to a negative, so let me use pink here, and then we'll change the 72 to a negative. These go away. We have negative 2 minus 8, which is negative 10, and we have 12 minus 72, which is negative 60. Divide by negative 10, divide by negative 10, those go away. Y equals 60 divided by 10 is 6. Two negatives give me a positive. Now I take my y equals 6 and I plug it into either one of those boxed equations. So 3x plus 8 times 6 equals 72. 3x plus 48 equals 72. Minus 48 goes away. 3x equals 24. Divide by 3, divide by 3, 24 divided by 3 is 8. So when x is 8, my y is 6. And I'm done. Okay, so let's continue with example 7. Okay, this is a y. Okay, so I need this to be a negative 4 so it can cancel with this one. So I'm going to multiply this whole top by negative 2, and that gives me negative 4x plus 2y, because negative 2 times positive, negative 2 times negative y is positive number. Negative 2 times 2 is negative 4. And then we've got a 4x minus 2y equals 12. Didn't change anything there. Those go away. Oh my gosh, those go away, and those go away. If that happens, we end up with a problem. And our problem is there is no solution to this. We have the null set for an answer. So if you come to a point where both the x's and y's are eliminated, what we basically have is two parallel lines that never cross. So each one of these equations, if you were to put it in slope-intercept form, you'd find the slope was the same, and they never cross, which means there's not a solution to the problem. Alright, which brings us to our last example here, example 8. We have 4x minus 3y equals 2. 8x minus 6y equals 4. And we want to make this a negative 8 so that we can add that and get 0. So we're going to multiply this top by negative 2. So I get negative 8x plus 6y equals negative 4. And on the bottom I still have my 8x minus 6y equals 4. Alright, let's do this. Those disappear too. And those disappear. So what do I get? 0 equals 0. Okay? Now on the last one, this answer right here did not disappear. We had our negative, let me rewrite that last one, 4x plus 2y equals negative 4, and we had 4x minus 2y equals 12, and that gave me 0, and this gave me 8. That is not a true statement, so that meant there was no answer. Up here, this is a true statement, it's just they're zeros. So when you get a number where 0 equals 0, you get infinity for the answer. Alright, so that is lesson 3.7, And your elimination method of doing these are in the story problems. And you're going to be doing 7 to 47 odd, and they are exactly like the ones I just did. I mean, we did, gosh, 8 different examples. So everything you could want is in this lecture, so that shouldn't give you any problem as far as figuring out how to do that. Follow your notes and you should be fine.